Hello everyone and a very warm welcome to this course on data build tool. This is DBT Complete Masterclass. My name is Prem Shende. I am a senior data engineer with more than 5 years of experience in the IT industry. Throughout my career, I have worked on building data pipelines, data warehouses, and data analyticals engineering projects in production environments. I'm really excited to be teaching this course because DBT is honestly one of the most powerful tool that has changed how data engineers and data analysts work today. And in this course, I'm going to take you from absolute zero, where you don't know anything about DBT, all the way to building production ready data pipelines on Snowflake. So whether you are a data analyst who wants to level up, a data engineer who wants to add DBT in your skills, or a student who wants to break into the data field. So this course is for you. We have more than 60 slides, 10 full sections, and every section ends with hands-on lab that you will follow along with me on Snowflake. Before we jump into actual course content, let me quickly introduce myself so you know who is teaching you and what background I'm coming from. So my name is Prem Shende. I am a senior data engineer currently working in the IT industry with over 5 years of experience. Okay, and I studied from SGS ITS Indore. In terms of experience, I have spent more than 5 years building real data engineering solutions. Uh, I have worked on the building ETL and ELT pipelines, cloud data platforms, and analytics system that are actually running in the production, not just theory, real systems. I have a deep expertise specifically in DBT. I have built and maintained production DBT projects on Snowflake, including writing models, test macros, setting up with CI/CD pipelines, and generating documents for the data teams. So everything I teach in this course uh, I have actually done in the real projects. So I'm SGS ITS in the alumni. So I completed my BTech degree from that college with deep expertise in data warehousing, SQL optimization, and cloud data stacks. And finally, I'm a passionate educator. I believe that the best way to learn data engineering is through practical examples. So every concept in this course will be explained with a real Snowflake demo that you can follow along with me. All right, now that you know a little bit about me, let's move on and talk about what is this course is going to cover. Thanks for taking the time to know me, and I'm promise to make this course most practical DBT course you will find. Thank you. Okay, so let's now talk about what exactly you are going to learn in this course. So first, big thing you will learn is how to transform raw data into analytics ready models. Right now, you probably know that data lands in your warehouse in a raw, messy form. So the DBT is the tool that takes that raw data and turns into the clean, well-structured, business-ready tables. Okay, you will have to understand like exactly where DBT fits in the modern data stacks and why it is so popular. Okay. Second, uh, you will learn how to install, configure, and integrate DBT with Snowflake. We will set up a DBT on your machine, connect it to a real Snowflake account, and also connect it to GitHub so your code is version control from day one. Okay, I'll walk you through every single step. Third, You will learn to build production grade models, write, test, and generate documentations. Okay, so this is the heart of DBT. So you will write SQL models, add data quality test, and with just one command, generate a beautiful data catalog that your whole team can use it. Okay, so and final feature like macros, Jinja templating, seeds, sources, snapshots, and pre-hook post-hook. Okay, so these are the feature that separate beginner DBT user from someone who can build real production pipelines. Okay, so by the end of this course, you will have all of these skills. You will be able to work confidently on DBT projects in the professional settings. Okay, let's move to next slide. Let's now look at the complete curriculum so you can see everything that's covered. So we start with section first. This is a DBT introduction. So what is DBT? Why was it created? Where it is fits in the data stack? All the foundational concepts we will see. Then second section, installation and DBT setup. Okay, so we will install DBT on your machine, set up a virtual environment and connect it to Snowflake. In the third section, models and overview. So we will start writing SQL models, understanding the project structure and learn about reference and source function. Fourth is materialization. So this is a very important section. We will cover all four materialization types, which are views, table, incremental, and ephemeral. So you will know exactly when to use which one. Fifth is seeds and sources. So how to load static lookup data and how to declare your raw Snowflake tables properly. So we will see into this. Next is snapshot. Snapshot, how to track historical changes in your data. Very useful for SCD. Like I think you know about this term, slowly changing dimensions. Seventh section is test. So data quality testing, one of the most important skill in modern data engineering. Okay. Next, macros and Jinja. So writing reusable SQL functions and using Jinja templating to make your SQL dynamic. Okay. Next, section 9 is DBT docs. So how to generate auto-generating full documents, right? With the full data catalog with lineage graphs. So we will look into this. 10th and final one is a pre and post hook. Okay, running SQL automatically before and after your model builds in Snowflake. So that is 10 full sections, and each sections has 3 to 4 slides covering objectives, concepts, code examples, and hands-on lab. So this is a complete end-to-end course. Let's go through it together. Welcome to section 1, DBT introduction. This is where everything begins. Before you touch any code, before you install anything, you need to deeply understand what DBT is, why it was created, and what problem it solves. A lot of students make the mistake of jumping straight into installation without understanding the why. And then when they hit a problem later, they have no mental model to fall back on. So in this section, we are going to take the time to build strong foundation. We will understand what DBT is, where it fits in the modern data stack, what the difference between ETL, ELT is, why SQL first transformations are so powerful, and then when you should use DBT core versus DBT cloud. By end of this section, you will be able to confidently explain DBT to anyone, whether it is a colleague or manager or a recruiter in the interview. Let's start with the learning objectives. Here are the 6 learning objectives for this section. Let me walk through each one so you know exactly what you will be able to do after completion of section 1. So first, you will understand what DBT is and the specific problem it solves in the data engineering. So this is a foundational. Second, you will be able to explain where DBT sits in the modern data stack, and you will understand the critical difference between ETL and ELT. Third, you will be able to identify the uh, key benefits of using DBT over traditional SQL scripting. There are many advantages, yes, and you will be able to articulate all of them clearly. Fourth is you will understand the difference between DBT Core, which is the open source version, and DBT Cloud, which is a managed SAS version. So this is a common question from the students, and we will clear this up completely. Fifth is you will be able to recognize DBT core building blocks, models, taste, documentation, macros. So basically, these are the 5 pillars of DBT, and everything in this course revolves around them. And last is you will you will know which database and warehouses DBT supports, and specifically why Snowflake is such a great fit for DBT, which is why we are using it is in this course. Now that you know what DBT is, let's talk about the 5 key reasons why you should use it. And trust me, once you understand these benefits, you will wonder how anyone managed data transformations without DBT. So reason one, SQL first. No new language to learn. This is huge. If you know SQL, you can use DBT. You don't need to learn Python. You don't need to learn how to use PySpark. You don't need to understand Java. Any analyst who can write a SQL statement can contribute to your data transformations layer. Okay, this is democratizes data engineering in a way no other tool has done. Second, built-in testing and data quality. DBT becomes with data testing out of the box. Okay, you can test that your primary keys are unique, that columns are not null, that values are within expected ranges, and that foreign key relationships and many things. Okay, and this test run automatically every time whenever you run your DBT model. Okay, you get a data quality validation for free every single run. Third, auto-generated documentation and lineage. You have to put one dbt doc command. It will automatically create your document. Okay, it will be in 3D format. You can simply click on your multiple dbt models. You can see the ddl, you can see the dbt model, you can see any file, and it will provide you lineage as well. Suppose one particular DBT model, it's dependent on other DBT model, that the proper lineage it will provide you. Next, modularity with the ref function and source function. So in DBT, you don't hard code table names. Okay, you have to use to reference other model, and source function also you have to use to reference raw tables. Understood? Means you use ref function to reference other DBT models and source functions to reference raw tables. So DBT builds a directed graph. I mean directed acyclic graph. I think you have heard about this term, DAG, right? Directed acyclic graph. From this reference and runs your DBT models in the correct order automatically. Means your runs your DBT model in the correct properly ordering in automatically. Okay, No more manually figuring out which SQL script needs to be run before which. Fifth, works with Snowflake natively. Okay, DBT pushes computation down into Snowflake. It doesn't pull data out to transform it. Snowflake compute engines runs all the sequels. This means you get Snowflake's full performance. Okay, and okay, so these five reasons are why DBT has become the standard tool for data transformation in data engineering field. Okay, now let's talk about DBT core versus DBT cloud. A very common question I get from student is, should I use DBT core or DBT cloud? Let me answer this clearly. On the left, we have DBT core. On the right side, DBT cloud. Okay. So in the left, this is DBT core. So this is open source version. It is completely free for you to install it via PIP. Okay. You run it from your terminal and you manage the environment yourself. It has all full feature set, all DBT models, test, docs, macros, seeds, snapshot, everything. Okay, so there is no magic. You see every step. And the right side, this is DBT Cloud. Okay, this is a paid software as a service product made by the same company, DBT Labs. It gives you a browser-based IDE. Okay, a job scheduler, CI/CD built-in, and team collaboration features also include. Okay, so you don't manage any infrastructure. DBT Labs manage everything for you. So now question is, which should you use? For learning purpose, always start with DBT core. You learn more, you understand the internals better, and it is free. This is what we are doing this project. Okay. And for production teams, DBT Cloud makes sense. When you have 5 or 10 data engineers working on the same project, running a schedules job every hour with alerting and observability. So DBT Cloud pay for itself in the time saved. Hi. So in this section, we will see how you can use DBT Cloud in your local machine. And we will see how you can integrate your DBT account with Snowflake and GitHub. Yeah, simply you can search DBT Cloud login. So it will redirect you into the sign up for DBT. So this is a sign up page. You need to fill uh, basic information here and you can click on your create account button. Okay. And it will send one uh, sign up mail in your Outlook or if you're using any Gmail. So you will get that email activation mail. So you have to complete your account. Okay. So here you can see I already created that account. So I'm going to log in here. So this is a login button. Whenever you will open your DBT UI, it will ask you to create one project. So this is a new setup. So for our demo purpose, we are giving demo project name for this DBT project. Yeah. Next, it will ask you to add new connection. So as you know, this is a DBT, right? We can connect our DBT with Databricks. Either you can create connection with Snowflake, right? Multiple things we can do. So we can add new connection here because we are going to connect with Snowflake. So there is a prerequisite for you. You should create your Snowflake account here. Okay, I already created one of the demo account. Okay, and this is a trial once. So the validity is for 28 days. So you can use this. Okay, so here you can see it is asking us to connect with Snowflake. There are multiple tools with we can connect, right? But in this our bootcamp session, we are going to use Snowflake only. So we can simply click on Snowflake. It will ask you for connection name and basic information. Okay, so it is asking you to provide account details, right? Account details, database, and warehouse name. So let's go on Snowflake first. So under this catalog section, right, you can see there are multiple databases. Let's create one database for us. So I will give DB name. Okay, so we created one of the database here, and it is asking for connection details, right? So you can simply click on your profile and there is account section, right? And you can click on view account details. Okay, in the account identifier section, there is a copy button. You can simply copy it and you can simply paste in the account section. I'm going to paste here. Database name, as you know, we created DB and warehouse. So let's check which compute section we have here in the Snowflake. So if you will scroll down, you will see in the under the manage section compute. So let's see warehouses. Okay, so here you can see we have compute WH. So this is a warehouse name. We are going to use this one. Okay, so I'm just pasting here. Okay, basic information we have filled up here. Connection name we can give Snowflake. Uh, we can give DBT Snow connection. So this name I'm giving here. Let's save it. Okay. Now you can see we have created one of the connection. Now again, you can simply click on your projects. Okay, demo project, it was that, right? So now we have created our basic connection with Snowflake. Let's edit this one. Yeah, yeah, DBT Snow con, right? So this one we can connect it, and it will ask you for basic information to be filled up, like your username, your password, and DBT. See, whenever we will connect, it will create one of the schema. So we need to provide the schema name. Let's see, we can give demo schema. Okay, let's test the connection. Okay, so here you can see this is completed. Let me save it. Okay, now it is asking us to integrate with GitHub repo. So let me add GitHub here. So no repositories found here, right? So we can do one thing. First of all, you need to go on your CLI. Okay, we can see in the integration section our GitHub. Uh, Let me create one of the repository in my GitHub account. So let's create new one. Okay, let's give this DBT Bootcamp 20261. Okay, this is available. So this is for learning purpose. Okay, let's create the repo. Okay, here you can see it has been created. Okay, so you need to configure your GitHub ID here. So for me, it's already has been added because earlier I worked on this one. So it has been added already. Okay, let's select our repo name here. That was DBT Bootcamp 2026. This is my repo name. Let's install that. Okay, here you can see the pop-up has come. Your account has been migrated. Congratulations, you have successfully integrated your DBT account with Snowflake and your GitHub repo. Okay, in the next section, we will see how you can create your first DBT model. Thank you. In this section, you are going to write SQL first real SQL model. We will see how the project structure is organized and see your transformation run inside Snowflake for the first time. The moment when you run DBT run and see your table appear in Snowflake, that is a very satisfying moment and you are going to experience it in this section. Let's check the learning objectives. So there are 6 learning objectives for the model section. Objective 1 is define what a DBT model is and understand how it differs from the writing raw SQL script. Models are not just a SQL files, they are managed, tested, and documented SQL that participates in the dependency graph. Second is understand the DBT project folder structure. We organize DBT models into the staging and Mars layer, and you will understand this two-layer architecture and why it matters. Third is use wrap function to create dependencies between models. This is one of the DBT's most powerful feature, and we'll see use it extensively. Fourth is a source to use the source function to reference raw Snowflake tables instead of hard coding the table names. You declare your sources and references them with source function. Fifth is runs model. Okay, so run models with the DBT run and understand every part of our output. So you will know that each line in the DBT run output means. And last is create your first staging model from a real Snowflake raw table. You will write a SQL and run it and verify the table appears in the Snowflake. Okay, so let's define exactly what a DBT model is. So a DBT model is a single .SQL file containing exactly one select statement. Okay, if you will put one select statement like select star from your source table from Snowflake you are keeping, right? So it will create one single DBT model, right? And you can save the file with .SQL extension. So that is a DBT model. Okay. Second point we have mentioned, models live in the model folder of your DBT project. Yes, under the model folder, we will keep all the model names and models, right? So typically we organize them into two layers, the staging layer, right? And marts, something like that we can mention. Third is a model reference each other using. Okay, suppose you have created one of the DBT model and you want to refer that DBT model into another one. So we will use this Ginger template. Here you can see double parenthesis ref and this is your model name. So like that we can mention it. And last is DBT run executes all your models in Snowflake. Right. So in Snowflake in the correct order determined by the DAG. Each model appears as a
table or view in the schema. You can configure in your profiles.yaml. We'll see in the next section.
This is the time to initialize your DBT project. I'm on the DBT Cloud UI. So simply you can click on the initialize DBT project. Okay, let's create one new branch here because this is a main branch in our GitHub repo. Let's create one of the feature branch and then I'll let you know how you can push your changes in your main branch. Okay, so let's create a new branch here. Okay, this is a branch name we are giving here. Okay, so under the file explorer, you can see all the analysis, macros, models, sets, snapshot, everything you will be able to see here. Okay, and same folder structure you will be able to see in your GitHub repo. Let's refresh this page because we have created one of the branch, right? Let's see. Yeah, now you can see there are two branches. Let me click on my feature branch. Yeah, so same folder structure you are able to see here. Right. Now let's create one of the DBT model. So under the DBT model section, you will be able to see by default, you will see two models to be created here. But these are the structure only. We have to compile them. Okay, let's see. Yeah. So these are two by default created models here. Let's create it. So here you can see, first of all, in Snowflake, let me show you. Yeah, this is our database which we created. There is no schema created as of now. Okay, when you compile your DBT model, by that time it will create that same table name and same schema in this DB. Okay, let's see. So let me copy this model name. There is a command section here. You need to put DBT run command and your model name. This is your model name. Let's hit the enter button. So DBT run succeeded, right? Let's see in our database. Let me refresh this page. Yeah. So here you can see we had created one of the demo SCH schema. Okay. Under the demo SCH, you will be able to see the tables. So we ran that first model, right? So that is the one temporary table which created here. Hi. So in this section, I will demonstrate how to create a DBT model using source tables. So first of all, I'll go to Snowflake. In our Snowflake environment, right, we need some source tables. So I have written create tables and insert statement for three tables: customer, products, and orders. Okay, so I'll run one by one quickly. Let me rename it because we need to specify the your DB name, right? DB name means database name and your schema name. So first of all, let me create one of the schema. We can give raw schema. Okay, let's create it. Okay, those so raw schema has been created successfully. Okay, now let's create first customer table.
Yeah, table has been created. Let's run our insert query. Same we will do for products and orders table. Okay, all three table has been created. Let's check in our catalog section. Yeah, so here you can see in the raw schema, we have created these three tables: customers, orders, and products, right? So now go on our cloud DBT. Let's restructure our model section. So I'm creating two folders here. First is staging. Yeah, and one more folder I'm creating it. It's March. Okay, under the staging folder, I'll create one source YAML file because we need to specify our source here. So let me create one of the file here. Okay. So this source YAML file will be in the YAML format. So let me put my query here. Version 2. Here we need to specify your sources. So we will give our source name is raw. Your database name you need to specify. Database was DB. And schema name, as you know, we had created demo SCH, right? So we are going to use the schema. And we need to specify the tables. Orders, customers, and products. Okay, let me save this source YAML file here. I think there is some issue. Okay, let me remove it. Yeah, now it's perfect. Yeah. Now under the staging, we will create one model. Make sure you have to use proper model name because same name will reflect in your Snowflake database table. Okay, so let's create one of the table. Yeah, so we will give stg underscore orders with .sql extension. So first of all, we'll see the data in our orders table. We can click to preview it. Hmm. So we have basic order ID, customer ID, product ID, quantity, unit price, and status, and all, right? Let's do some small transformation for this model. Okay, we will rename it. Basically, we can give alias on the column level, and let's check. Do we have any null? Yes, we have some null values. Okay, in the ship date column. So we will filter it out. Okay, in our DBT model. Let's see. First, we will create one city with source as, we can give simple select query. From here we need to specify our source. So just now we created one source YAML. So here you can see source name is raw, and these are the table names. So let's specify it. We want to use orders table because we are creating stage order model. So you can use underscore underscore source. So that was a shortcut. Underscore underscore source you need to specify. So here you need to specify the source name and your table name. So our source name is raw, and table name is orders. Yeah, that's it. Now we can do small transformation on it. So I'm creating one another city. So here you can see this is our order table. This is the DDL. So order ID, customer name, product ID, right? And we have few null values also in the ship dated column. So we can give one filter condition as well to do a basic transformation. Okay. So yeah, we can select order ID should be your OID. Second was product ID as PID, and customer ID, cust ID, right? Other columns are okay, unit price, status, and ship date. Ship date. Okay, from our source means basically first city. Yeah, and we can give one filter condition. Shipped date is not null. Now this time you have to give simple select statement from your second city. That's it. Now we are going to save this model. Okay, now you can give in the DBT run command section, you can give the command DBT run hyphen hyphen select your model name. You can simply copy your model name to click on this one and paste it here. Let's run it. It failed. Okay, so there is a one comma missed. Let me add comma, and we can give this is a PID, not product ID. Let me save it. Okay, there is no more changes required. Okay, let me save it. Yeah, yeah. So our DBT run command has run successfully. So let's see the table has been created or not in our Snowflake. This is a demo SCH where our all table will be get created. Here you can see stage orders. Let's see the data preview because we had added one of the filter condition not null, right? So that's why we are able to see only these things, right? So like that, you can use your source table inside your DBT model. Okay, that's it in this section. Let's see in the next section. Thank you. Welcome to section 4, materialization. This section is critically important. Once you start building more models, a key question will come up. Should this model be a table, a view, or something else? The answer to this question has massive implications for the performance, cost, and freshness of your data in Snowflake. Basically, DBT gives you four materialization strategies, and each one is designed for a different use case. By the end of this section, you will know exactly which one to choose and why. Let's look at the objectives. Let me introduce all four materialization types and their most important characteristics. First is view. This is the default materialization for staging models. A view is a virtual object in Snowflake. No actual data is stored. When someone queries the views, Snowflake runs your select statement fresh every time against the underlying raw tables. Views are essentially zero storage cost, but every query recomputes the transformation from the scratch. Use this view for staging models where freshness matters more than query speed. Similarly, we have table. So this drops the uh, full table on every DBT run. Means this drops and recreates the full table on every DBT run. All rows are stored in Snowflake. Queries on tables are fast because the data is pre-computed. But if you have 100 million rows and a full table rebuild takes time and uses Snowflake compute credits, use tables for your MART models. The final analytics ready tables that your BI tools query repeatedly. Third one is incremental. This is the most powerful and most sophisticated materialization. On the first run, it behaves like a table and load all the history in your data, in your table. On every subsequent run, it only processes new or updated rows and merge them into the existing table. If you have a fact table with 10 billion rows, excuse me, and you do not want to rebuild the whole thing every hour, incremental lets you only process the last hour worth of data. So this saves massively amounts of compute time and Snowflake credits. And last one is ephemeral. This is the most misunderstood one. Ephemeral model is never materialized in Snowflake at all. It is compiled as an inline city inside any downstream model that refreshes it. Think of it as a reusable piece of SQL logic that only exists at compile time. Zero storage, zero compute for the model itself, and use this for intermediate transformations you want to organize in code but don't need as a standalone objective in the Snowflake. Now let's do some hands-on on each materialization. See you in the next session. Thank you. Hi. So in this session, you will see how we can create one view materialization. So this is our DBT UI. Let me go to our DBT models folder. Yeah. So we will create one model in the staging folder, and we can give name stage orders v with .sql extension. To specify the materialization, we do use Jinja template. So let me type it here. You can give config. So we have given materialized type as a view. Now same code we can write here. First city we will create source as select star from, let's create one of the view, right, based on our existing model. So we can directly use our existing model. So we can directly use ref function. So there is a one shortcut key. You can directly put underscore underscore ref. So it will give you the proper Jinja template here. Now you can specify your this model name. We can simply copy it. Right. Yeah. Now let's create only two or three columns. We can put it here. OID as a order ID from source. That's it. Let me save it. Okay, I'm going to copy the model name, and same we can put DBT run command here and our model name. Yeah, DBT run command ran successfully. Let's verify in this Snowflake. Let me refresh this page. Okay, so as you know, we are using DB database, and this is a demo schema, right? So under the view section, you can see our view has been created. Let's preview the data. See, order ID, customer ID, and status. So the first materialization is view, and this is the default in DBT. When you run this, DBT does not store any data in the database. It just creates a virtual view, meaning every time someone queries it, it goes back and reads from the source table fresh. So this is the great when you have a data is small, or when you always want to latest data without any delay. The downside is, if your source table is huge, every query on this view is going to be slow because it's scanning everything from the scratch each time. So use view for lightweight transformations where performance is not a concern. Next is table materialization. Here, DBT physically creates the table in your database. So the data is actually stored, but the important thing to understand is every time you do DBT run, and it drops the old table and rebuilds it completely from the scratch. Okay, let's create one of the DBT model. Okay, I'm going to use this staging folder again. Let me create one of the model. Let's create STG customers. So in the source YAML file, we already specified this customer table. This is from raw schema, which already exists in our Snowflake. So we are going to use as a source table, this customer. Okay. Now we need to specify our materialization type here. Yeah. So we have given materialized as a table. Now we can create one city. Let's see the detail of the customer table in the Snowflake. So it was in our yeah, raw schema. Yeah. So these many columns we are using here. Okay, city, country created at first name, last name, phone. Okay. Yeah. So we can use source. Source is raw and table name is customers. Now we can do any transformation here. Let's pick few columns only. City, country created at, and email we can put here, and phone. We can give one small transformation here, alias from our CTE. Yeah, so we have given materialization as a table. Let's save it and run our DBT model. Yeah, so here you can see it has saved successfully. Now we can run our DBT model. Hmm. So we can put this DBT run command, DBT run hyphen hyphen select, and our model name STG customers. Please and press the enter button. Yeah, so DBT run command ran successfully. Now let's check in our Snowflake catalog. So our schema is demo SCH. Under the table section, you can see stage customers. Let's preview the data. Yeah, so here you can see these many columns we put it in our select query. So, and this is a alias we had given for first name and last name. So we are able to see here. So like that, you can create any model for this table materialization. This makes query is very fast because the data is already setting up there, right? No recomputation needed. But the trade of this, like if you have millions of row and rebuilding the whole thing every run is going to be expensive and slow. So the table is best for small and medium data sets where a full rebuild is affordable. Okay, and this table materialization, every time you do DBT run and it drops the old table and rebuilds it completely from the sketch. So full refresh every time. This makes query very fast. Okay, all right. So now we are going to talk about incremental materialization. And honestly, this is the most important one to understand if you are working with production pipelines. So first, let me tell you the problem it solves. Imagine you have order table with 500 million rows, and every day 15,000 rows newly coming in your orders table. Okay, now if you use table materialization, means materialize as a table, DBT will drop entire table and rebuild all 500 million rows from scratch every single day. That is extremely slow and expensive. This is exactly where incremental comes in. So the idea is very simple. First run, it will, what it will do, it will build the full table with all rows, and every run after that only process new or changed rows and merge them into the existing table. So instead of processing 500 million rows, you are only processing today's 50,000 rows. Massive difference in the cost and time. Now let's discuss on, there are few strategies, incremental strategies. So we will see one by one all the full strategies. First is your append. Second, merge. Third is delete. Plus insert. And fourth is your insert override. So see you in the next section. We will one by one we'll do hands-on on each strategies. Okay, see you there. First is append incremental materialization strategy. So let's talk about this one. So this is the simplest one. It is only insert new rows. It will never update or delete any existing record. Okay, let me create one of the append model. So in this section, we are going to use a Mars folder. I'm creating one of the model. I'm giving simple name, orders append. Yeah. Now we need to specify our configuration here. We will give our materialization type and incremental strategy over here. Yeah. So here you can see materialized is equal to incremental we have given, and this time we are not giving any unique key. Now we can give incremental strategy append. Okay, perfect. Now, uh, in this model, we are going to use our source table, which is nothing but orders table from our Snowflake raw schema. So I'm creating one city here. We can specify our source here. Source name, as you know, we are using raws, and our table name is orders. Yeah. Now we can use one select query, and we can put few column names. We have order ID, customer ID, status, and shipped date from our CTE. There is a one main thing we have to use here is incremental condition. Basically, we are going to use one filter condition. Let me type here. If, okay, we can give is incremental condition, and we can use one more thing, percentile and if. Yeah. Now here we can give our where condition, where shipped date select max of shipped date from, either you can use source or you can use, there is a one another Ginger template, this. No need to specify any table name or city name here. You can simply use this one. Okay. Now let's save it. Notice there is no unique key here because we are not checking for duplicates at all. Whatever new rows come in, just insert them. So if the same order ID comes in twice, it will be inserted twice. DBT will not stop it. Use this only when your data is immutable. Okay. Now let me run this DBT model. Let me copy the model name, and we are going to use same DBT run command. Yeah, it has run succeeded. Yeah, here you can see the lineage also. Lineage is nothing but graphical representation. Here you can see this is a raw table, right? And we are going to use in our one of the marts folder. Basically, we are referring it. So this is a lineage. Multiple tables, if we are adding here, so it will create one proper lineage graph here. Yeah, so let's verify in our Snowflake. So the table name is Hmm. Select start from our this proper orders append. This is our table name we can put here. Let's run it. So here you can see there are total 12 records, right? There are total 12 records with these many columns. Now we are going to append this 3 record. Okay, let me run this. Okay, so 3 records inserted. Let's verify it. Okay, so there are total 21 rows are returning here. Okay, let's verify our main table. Here you can see still we have 12 records. Yeah. Now go to our DBT. Let's run this DBT model again. Let me restart this studio. So this is our model orders append, right? Now we are going to run this one. And we can add our model name. Okay, so DBT run succeeded. Let's verify the records. Earlier we were having 12 records there. Now rerun this one. See, so here you can see 15 rows inserted without impacting our history. So this is how you can see your all 3 records which inserted. We have second incremental strategy is merge. Now we are implementing that in one of the model. So let me create one of the model here. And this time we are giving name orders merge with .sql extension. The structure will be same for this one as well. Only the thing is we are going to use incremental strategies merge and we can give unique ID because we need to specify the unique ID. I think you have heard about merge or upset logic, right? So in merge into statement, we need to specify the hash key column or one unique column we need to specify there, right? So same thing we are implementing here. Okay, let me copy this particular model here because the same structure we are going to use and we are going to use same source table as order. Yeah. So here you can see incremental strategy. We will change it to merge and we can give one unique ID. Mm, yes. Unique key is equal to we can give one of the column name. Let me check. Okay, we are going to use this orders table, right? So let's check. Okay, so order ID we can use here. I hope we don't have any duplicates. Yeah, all are unique only. Okay, perfect. Now the structure will be same. We are creating one city based on our source table, and we are using these many columns here with the same incremental condition, right? Filter condition. Okay, now I'm going to save it. I would like to tell you first time whenever you will run your DBT model with materialize as an incremental, it will create your table and from second time onwards it will append the data, means basically upside logic will implement there. Okay, so let's create it. Let me show you. This table doesn't exist here. See, here you can see this table doesn't exist. Okay, let's recreate this one. So as you know, we all time we use dbt run command. Hyphen hyphen select. You can select your model. This is orders merge. Okay, let me run this. Okay, so DBT run succeeded. Here you can see we ran this model, right? Let me walk you through the DBT generated logs. So as I mentioned, this will use merge statement here. Okay, so this is first thing because this is your first one, right? That's why you are able to see the create or replace transient table. Means basically it is creating the table. So this is how this is a compiled version of your code. Okay, let's verify this one. Earlier it was not exist. Now let's check. Perfect. So you are able to see the all column names and with total 21 records are there. Okay, so there are total 21 records. Okay, so let's update a few records and one record I'm inserting here. Okay, so let me run this update query for our source table, right? Now let me add 2029. Okay, so I'm just inserting this record. Now rerun our DBT model. Let's see whether it is inserting or not. We can cross check. Let me rerun this. Okay, DBT run succeeded. Let's walk through the DBT generated logs. So as I mentioned, it will create first time table, right? But when you are running it second time, it will work as a merge statement. So here you can see merge into your db demo sch. This is nothing but your target table. Okay, using your this particular condition on your order ID, because order ID is the primary key for us here. Okay, and same when matched then update, when not matched then it will insert. Okay, now let's run this. I mean, we can simply cross check in our table. Earlier, we were having only 12 records. Let's see. No, I think we are checking in wrong table. We have to check in orders merge table. Okay, let's see. We have added this row 4001. 4001 inserted, right? And for this 1001, the status also updated to pending, right? So this is how you can implement your uh, incremental strategy as a merge. It will be very useful for production pipelines and all. Thank you. Hi. Now we will talk about our third incremental strategy, which is delete insert. Okay. There are two steps happening under this foot. Let me prepare one of the model for this one also. So under the staging folder, let's create one more DBT model, which is order underscore. We can give delete insert with .sql extension. Okay, so in this delete insert incremental strategy one, here also we are going to use same structure which we used in our previous video for merge one. Okay, I'm just copying the entire structure from this model and pasting in the delete insert one model. So there is a small change. We have to change the incremental strategy. It will be your, in the lower case, you have to mention delete plus insert. That's it. You have to do here. As I mentioned, for first time, as you know, this is a incremental materialization. It will create the table, right? So I'm going to run one dbt command, dbt run hyphen hyphen select and your model name. So basically there are two steps. DBT first deletes all rows from the target, no, from your target table where the unique key or your primary key matches the incoming batch. And second step, then it insert all those rows fresh from the source. Okay, it has run successfully. Let me open the logs. Let's verify in our Snowflake whether table has been created or not. So I'm putting one command select star from, and our table name is delete insert orders delete insert. Let's check. Okay, so here I can see we have this table with 23 records. Okay, now let's rerun this DBT model. Let's check whether it's changing in the internal DBT generated logs or not. Okay, we are rewriting it. So basically, for your understanding, like the name says, it works in two steps, right? Step one is DBT looks at the incoming batch, finding all the matching order ID records in the target table and deletes them. Second is it takes those same records from the source and insert them freshly into the table. Now the difference between this and the merge is merge uh, does an in place update, meaning it just updates the columns that changed, but delete plus insert completely removes the old record and puts a brand new one in its place. So when would you pick this over merge? Two situations. First, when you when your source data has correctness or fixes in the whole batch from the records and you want to cleanly replace them, not just update a few columns. Second, sometimes in certain warehouse configurations, merge can be expensive or slow, and delete plus insert gives you better performance. So on Snowflake, both merge and delete insert are the well supported. So it really comes down to your use case and what makes more sense for your data. Okay, it ran successfully. Let's read the logs. So here you can see this is the one delete from, right? Delete from your table. And second is your insert. I hope you understood this point. Okay, let's move to next session. All right. This is the last strategy, insert overwrite. Now, this one is completely different from other previous three strategies, right? All work at row level, but this is a partition level, right? Insert override works at the partition level. So first, what is the partition? Think of slashing your table by date, right? Like quarterly wise, right? So January data is one partition, February is another, March is another, right? So this is sliced your data, right? And each date its own separate chunk. Now, what insert override does is instead of touching individual rows, right? It picks the entire partition for the incoming data and replaces it completely with fresh data. One simple example, today's is 24th May, right? New orders have come in for 24th May. Insert overwrite will drop everything in the 24th May partition and it will reload it fresh, right? So rows from the other dates completely untouched, right? Let me implement this thing in the model level. So let's create one model under the staging one. Orders. We can give insert overwrite with .sql extension. Now here also we are going to use same structure. Let me copy the structure from the merge model. Okay, so there is a small change. We have to use, we no need to specify the unique key here. I'm removing it. Incremental strategy, we can give insert overwrite. And the main thing is we have to give partition by. Okay, partition ID we need to specify here. So you can give partition by. In curly braces, you can add your field name and the field data type. Okay, so field name is, okay, let me add a double quote. Okay, shipped date because we have that column. Now we can specify the data type. I think it is a date. Let's verify. So here you can see all fields are in the date format only. Okay, so we can give this as a date. What is happening with my keyboard? Date. Okay, perfect. And the structure will be same. We are creating one city and the source table is order. We are taking these many columns. Let me add one more column here. Mm, current time stamp as DS. Okay, let's run this. And we can copy our this model name and hit the enter button. Okay, so DBT run succeeded. Let's walk through the DBT generated logs. So in first case, it is creating a table. That's it. Okay, let's verify in our Snowflake also. Okay, This is our model name. Let's put it here. Okay, it has been created, and this time here you can see one timestamp we had added. So this is the case. Okay, and there is a one condition, right? This filter condition. There are multiple ways to handle it. Okay, now we have used our shipped date, right? You can give multiple things here. Suppose you don't want to give any particular max date. You can give current date minus 7, means 1 week ago's data, right? It will get inserted and overwritten. So you can do like this. Okay, thanks for this session. Let me see you in the next section. Thank you. Hi, so in this video, we will talk about our fourth materialization, which is ephemeral. So this is one quite unique compared to other three materializations. So with the view, table, and incremental, all of them create something in the database, right? A view object, a table, something you can see and query in the Snowflake. But in the ephemeral creates absolutely nothing in the database. So no table, no view, no object at all. So the obvious question is then what does it do? I'll prepare one model so you will get understanding on that. Okay. So let's create one model. I will be using this staging folder only. Let's create one model. I'll give this time ephemeral orders.sql. We will provide the configuration and we have to give materialize type as a ephemeral. Okay. Now just create one city. Here again we are going to use our source table, which is order. As you know, we have a source name as a raw. We already mentioned in our previous videos in our YAML file, right? There we have implemented all the things. We have given all the configuration there. So we are using raw source and the object name is orders, right? So we have created one CTE. Now we can give one select query and for this time we can use order ID and customer ID, status and shipped ID from our CTE. And one filter condition also we can give here. Shipped date is null. Okay. So we have created one of the model. Let me save it. I'm copying the model name and let's run our DBT model here. Okay, it succeeded, right? Now let's verify whether it's created in our Snowflake catalog or not. So I'll go to our catalog. Yeah, this is our database. And our target schema is a demo schema, this one. Under the table section, we can check. See, it is not created. That's what I mean. Means whenever you will provide ephemeral materialization, it won't create any table in your database. Okay, but the main concern here is you can use that particular model in our different DBT model. Okay, I'll explain you that also. Now we have created this particular model, right? Let's create one new more. Okay, I'm creating it. Now this time we are giving config materialization as a table because we are creating separate model. We are going to use ref function and our model name is ephemeral orders. Okay, let's save it. I'm going to copy this model name and we will run in our run section. Okay, I'm changing the model name and let's run it. Okay, the run has succeeded. I'll show you the lineage also, so you will get better understanding on this. Yeah, here you can see we have given only ref function here, but in our ephemeral orders model, we are using materialization as a ephemeral. Okay, and which is taking reference from our source table, means this raw orders table. So that's what you can see here. Without creating this particular intermediate table in our Snowflake, you can, without create in your database, you can refer in your final model, right? That is a use case, right? So there are multiple ways to say that, like it is based for small lightweight reusable code logic that does not need to exist as an standalone object in your warehouse. Okay, avoided it for heavy or complex transformation that are referenced by many other downstream models. And in one line you can say ephemeral is not a database object, it is a reusable city that dbt injects into whatever models reference, right, it at compile time, right? So that is the ephemeral materialization. I hope you understand it. Thank you. Welcome to section 5, seeds and sources. So seeds and sources, these are two distinct but related features in dbt, and together they handle two very different types of data that every real project needs. Basically, seeds handle static and slow changing lookup data like country codes, product categories, or cost center mappings, right? Whether sources handles your raw incoming data from your external system. Like in our case, we are using Snowflake. So basically, we are using that table as a source, right? So the tables, right? Basically, we are taking reference from our source, right? For that reason we are using sources. So both features makes your dbt project more robust, better documented, and easier to maintain. Let's dig in. Let's discuss about first seeds. So basically I have mentioned few key features of our dbt seeds here. So first is dbt seeds are csv files that dbt loads as a table into Snowflake, right? You have to simply specify your CSV file in your DBT folder. DBT seeds folder is there. You need to specify your CSV file and you have to simply run your DBT seed command. It will create one table inside your Snowflake database, right? Second, this is perfect for static lookup and mapping data. Okay, data that rarely changes and has no pipelines there, we can use this DBT seeds. Third is reference seeds, just like any other model using a ref function. See, if you are creating this table inside your Snowflake, right? And inside your DBT folder also, means inside your model folder you have, and you are using this particular model, definitely it will create that table also. So that particular model you can refer anywhere in any other DBT model, you can refer it. And last is your sets are version control alongside your SQL. Basically, this is a huge advantage. If you need to update a country code mapping, you edit the CSV, commit the changes to Git, and run dbt set, and the Snowflake table is updated. You have to full audit trail of every changes in your Git history. There are, we can say, limitations of seeds in that they are not suitable for large data sets. For anything more than a few thousand rows, use a proper pipeline. Sets are small also, right? Relatively static lookup tables. In next video, we will do some hands-on on DBT sets. Hi, let's see how DBT sets works in DBT. So basically, in the left hand side, you can see this file explorer. Inside this one, you can see one DBT seeds folder also, right? Under this seeds folder, you have to create one CSV file. Let me give one name, country codes. This is a CSV file, right? So we will give one extension .csv. I'm just creating this particular file here. Okay, so I have basic CSV file here. So here you can see I'm giving this particular header. So these are the column names, basically country code, country name, and region. And these are the records we are inserting here. Okay, so these US, IN, GB, DE, AU, these are the country code, and United States, India, right? These are the country name and these are the regions. So I'm going to save it. Once you save your CSV file into your this seeds folder, you can give one command, tbt seed, and hit the enter button. So if you are giving country codes, right? So same name table will be created in your simply Snowflake database. Okay, so it has ran successfully. Let's verify in our Snowflake database. Let me refresh this page. We can check in our target schema, which is demo schema. See, here you can see it has created with this name, country codes. Yeah, here you can see this is the DDL of this particular table, right? This is a based feature actually. You no need to specify any uh, what to say, any data type and all, right? It will create automatically your DDL with your data. Let me preview the data. See, country code, country name, region with all the records. That's how DBT seeds work in DBT. Thank you. Hi, welcome to section 6, snapshots. So in this article, we are diving into one of the DBT's most powerful feature, which is DBT snapshot. Imagine this, you have a table that gets updated regularly. Maybe a customer profile table where details like email address, phone number, or address something change over the time. If you only keep the latest version of each record, you will lose your historical data, right? Means valuable insight you will lose. So this is where snapshot come in. Snapshot allow you to track and store historical changes in your data, helping you to analyze how records evolve over the time. Whether you are dealing with slowly changing dimensions, means HCD, right? So DBT snapshots provide a simple and scalable way to retain historical data without requiring complex ETL logic. Let's check out the uh, upcoming videos. I'll explain in a better way. So our question is, what are snapshots in DBT? So snapshots are a way to track and store changes to your data over the time. It allows you to maintain a historical record of your tables, capturing how specific rows evolves with each update. Think of them as your data's time machine, giving you the ability to look back and see what a record looked like last week, last month, or even last year. Right? So that is your snapshot. Means basically you are maintaining your history, and you can do many analysis on your history. Right? Now, question arises: why do we need snapshots? Let's say you have a table with customer information. Every time a customer updates their email, or you can say phone number or address, right? So the old information is overwritten all time. So without snapshot, there is no way to see what data looked like before the updated. So this can be a problem if you need to track track the changes over time, analyze trends, ensure compliance and audibility, recover from accidental changes, right? So snapshot help solve these problems by creating a version history of your data. Now come to this SCD type. First of all, what is SCD? Basically, in data warehousing, snapshots are often used to handle slowly changing dimensions. Basically, we do this kind of activity on dimensions table, right? So SCDs refer to dimensions that change over the time, like customer address or product price. There are different strategies for managing these changes. So basically, uh, there are many types. So I'll explain you type 1 SCD and type 2 SCD first. Basically, this DBT snapshot takes care for SCD type 2, but I'll explain what is SCD type 1. So basically, SCD type 1 override the old data with new data, means it doesn't keep any history. Whatever data is coming, it's getting updated, means it is overwriting old data. And now come to our SCD type 2. So SCD type 2 keep both the old and new data. It's allow you to track historical changes. This is where DBT snapshots shine, right? So with snapshots, DBT makes it easy to implement type 2 SCDs, automatically capturing changes and maintaining historical records. Let's deep dive into it, and I'll write one code for snapshot also. Let's see in next video. So in this video, we will do some demonstration on snapshot. So there are two strategies in DBT snapshot. First is related to timestamp and second is related to checks. Okay, we'll see one by one. So here you can see left hand side, you can see file explorer. Okay, there is a one folder snapshot. It is already been created. So under this folder, you have to create one of the snapshot table. Okay, we are creating one new file here and we will give the name we can give order snapshot, and we will give this SQL extension. Okay, so our SQL file is created here. Now let's write the code. So as you know, this is a snapshot. So we need to specify one Jinja template which is related to snapshot. Okay, so you can give one Jinja template like this one. You can give curly braces with percentile and just give snapshot and your snapshot table name. So we have given this order snapshot, right? Snapshot, then order snapshot name we have to provide, right? Now we can end this also. Yeah. Inside this block, we have to write our code. So as you know, first we will specify our configuration. So we will provide config. Unique key we have to specify here. It will be your order ID. Next column we have to give strategy. This time we are using timestamp and updated as. You can give one column name. So we can give load date time. Basically, this is a column name. We will specify it in our when we will write one our SQL query. Yeah. Now we can give our first select query. Okay. I have already written one source YAML file. Basically, we are using order table as a source from our Snowflake from a raw schema. So I'm using source function here. Our source name is raw and object name is orders. But this time we are not providing all the column names here. We will specify few columns: order ID, customer ID, status, shipped date, and we can give current timestamp as your this column name, load date time. I think I copied wrongly. Okay, I have to specify this parenthesis also and load date time. Perfect. Now let me save this one. Okay, so it's saved. Now we have to provide one command here, DBT snapshot. Okay, it failed. I think I given wrong unique key. Okay, let me rerun this dbt snapshot command. Okay, it failed again. Updated at. I think we have given as. Okay, this is a mistake. Let's save it. Okay, it ran successfully. Let's verify in our Snowflake. Let me refresh this page. Yeah, here you can see it has created. Now let's verify the column names. I think it will add new columns also. Yeah, first we will see for the detail. So here I can see these were columns we added, right, till here, and these are the extras one, means dbt stdid. Okay, updated at and validate from and valid to, these many columns it's created. Now we can click on preview the data. Yeah, here you can see it will give you current timestamp. Okay, like that you can give in. Suppose in future you made any changes, right, in your particular source table. So it, whenever you will run your this particular snapshot, it will give the all history. Okay, and it will give you proper timestamp thing here, updated at, valid from, particular timestamp it will provide you, and this is based on your timestamp. Hi, welcome to section 8, macros and Ginger templating. If you have been writing SQL for a while, you have almost certainly repeated yourself. I mean, same calculation, same logic, we paste everywhere. So, macro solve this issue. Means same case statement pasted everywhere, the same type of casting logic scattered across your code base. So macros can solve this. I will tell one definition about this macro. So macro is a reusable piece of SQL logic, like a function in a Python or JavaScript that you define once and call anywhere. Combined with Jinja control flow features, macro let you write dynamic SQL that adapts to different environments, and it iterates over list and accept parameters. This section we will level up your DBT code quality significantly.
All right, so now we are moving to next topic, which is DBT macros. So before I show you the code, let me first tell you why macros exist. Imagine you are working on project and you have 20 models, and in every model you are writing the same logic, maybe converting cents to dollars or writing the same case when block for status labels or applying the same discount formula. You are basically copy pasting the same SQL across 20 files. Now tomorrow your business says, hey, the logic has changed. You go and update the all 20 models one by one. That is a maintenance nightmare, right? Maintenance nightmare it is. And also a risk. What if you miss one file? The This is exactly the problem macros solve. The idea is very simple. Write a logic once and call it everywhere. Now let me show you few examples. So basically, what I will do, I'll create one particular function under the macros folder. So here you can see this is our macros folder, and I'm going to create one macro here. So let's give one example. Okay, cents to dollar. What am I bad? And with .sql extension, we have to save it. Yeah. Now what we can do, whenever you create one macro, right? That time you need to provide one Jinja template, which is nothing but in curly braces, you have to give percentile macro and your macro name, cents to dollars, right? And we will provide one column name, and you have to close it also. Again, parenthesis with percentile int macro. Perfect. Now here you can write your logic. So basically what we are going to use, our main concern is we will provide one column. Okay, basically cents to dollar we are changing it, right? So in braces you can provide your column name, right? And we can divide by 100.0. Okay, that's it. And I'm going to save it. So your function has been created here, means the macro. Come to our Snowflake UI. So I will use this source table. This is order table, and I'm going to use this one. And we are going to use this unit price column, which has been written in this. Okay. Okay. So in our source YAML file, I already added that particular raw table. Let me show you that also. Yeah. So we are giving here the source name, and this is database name, raw schema, and these are the tables. So we are going to use this orders table. Okay. Let's create one model under the Marts folder, and I'm going to give fact orders dot SQL. Hmm. So I'll create one table. As you know, we have covered materializations in our previous videos. So I'm going to give materialize type as a table. So first of all, we need to give config block, and yeah, we are going to use this materialize table. Okay. Let's create one city, and we are going to use all columns from our source table, and our source name is raw, and we are going to use orders table. Perfect. Now we can uh, give one select query, and few columns we are going to use there. So how many columns we are here? Okay, multiple columns here, but we will take only orders, order ID, customer ID, unit price, and status. Okay.
Let's write it here. Order ID, customer ID, unit price. And we are going to use one more column here. Basically, we are appending it. So here we have to call our macro. Okay, we are calling our macro inside your DBT model. So the syntax is in double parenthesis. You need to give your macro name. Macro name just now we created here, right? Where is that? Yeah, this one. So same name you have to give there. Okay, let me copy from here and inside your model, we will add that. Okay, I'm going to paste it here. So at this place, we have to provide our column name. So as I mentioned, we are using our unit price column here. Perfect. And we can give one alias. Alias we can give unit price dollar. Okay, perfect. And last column we can give status from our CTE. Perfect. Now I'm going to save it. Yeah, and we can simply run our DBT model as usually. So uh, DBT run hyphen select and your model name fact orders and hit the run button. So this is the simplest example. I created a macro called cents to dollars and it takes column name as a divides it by 100. So in the model, I just call this particular template, Ginger template, right, which is nothing but a macro for us. And it look at the compiled code. I'll show you that also. Okay, it has run successfully. Okay, let's verify in our Snowflake. So I'm going to use select star from DB schema with we have a target schema is demo and our fact orders. Perfect. So here you can see one new column has been added here and DBT has replaced that one line with this one automatically. Tomorrow, if the logic changes, I will update the macro at one place and done the process. Right. So here you can see it has changed it to dollars. Right. There are multiple examples you can take. Right. What you can do for the discount purpose, also you can use it. Right. And you can create multiple case statement that also you can use, and there are various examples through you can write your particular function here and you can call from anywhere. Okay, in any model you can add this particular macro and call it. Thank you. Welcome to this section. This is pre and post hooks. This is our final section and it is a great one to finish on because hooks make your DBT workflows production ready. Here is the problem hook solve when DBT builds a model in Snowflake. It just creates the table, but in production, you often need to do thing around that table creation. Set up the right session context before building it, or grant the right permissions after building, or log the build to audit table for monitoring it. Without hooks, you would need a separate script or manual steps to handle these things. With hooks, you tell DBT to run specific SQL statement without any manual effort. Automatically, your SQL statement automatically before or after every model build, and your pipeline becomes fully self-content. This is the last section. After this, we will equate production. There are a few learning objectives for pre-hook and post-hooks. There are 6 final objectives for this course. First objective is understand what pre-hook and post-hook and the typical use cases for each. Second, configure a pre-hook to run SQL before a model builds, setting session variables, creating schemas, and configuration roles. Third is configure a post hook to run SQL after a model builds, granting Snowflake privilege logging to audit tables and all. Objective 4, which is write hooks in line in a model config block uh, where globally in DBT project YAML and understand when to use each approach. Fifth, use DBT hooks to log model run metadata and an audit table in Snowflake, creating a run history so you can it query. Okay. And last is chain multiple hooks together in a list because you often need to do more than one thing before or after a model builds. Hi, let's create one model where we will cover our pre-hook and post-hook. So we will talk about first is pre-hook. Okay. So what we can do, we will create one model under this marts. So I'm giving one particular code and we will give the name as a pre-hook orders table with .sql extension. And as you know, first we will provide one Ginger template with our config. There we will add materialization, right? And we will add our pre-hook also in this case. So what we can do, first of all, we can give config. We are going to use table only and we can add pre-hook. Pre underscore hook equal to in your square bracket, you can put your command. You can add create table statement or you can add truncate, you can add insert, you can add drop, anything you can provide here. Okay, let's create one table. Create temporary table and we will provide a source name which is uh, db.demo and we can give demo schema, that's fine. And you can give the table name, temporary table name, it will be temp order as select star from your DB schema with the raw schema and your table name which is orders. That's it. It has been closed, right? Now we can directly uh, create one city here with city as and one select query. This time we will provide this table name because it will create before creating our DBT model, your create table statement will run. So we can directly use here and select star from our CTA. Now I'm going to save it and we will run our DBT model. So as you know, we need to provide one command DBT run. You need to select your model, which is pre-hook orders. Okay, it has run successfully. Let's open the logs. So here I can see in pre-hook, this creating as a table, and this is our code. Okay, let's verify in our Snowflake UI. So yeah, select star from our temporary table name. but we have given temporary, right? So I don't think it will create that one, because that is a temporary, it will be exist only for that session. So we can give pre-hook orders. See, without giving any source information, it has created that particular table. Means we had created one temporary table, okay, and that table we have used inside our city, and using that city we created this particular model. So like that you can add pre-hook in your pre-hook section. In the next video we will see how DBT post-hook will work. Okay, thank you. Hi, in this video we will do some hands-on on post-hooks. Uh, before moving to start, I would like to tell you we need to create one model log. I'll tell you step by step. First of all, we will create one model log table in our Snowflake database. So let me create it. Select table, sorry, create table DB with raw schema and model log. And we will add model name with varchar data type, status, varchar, and run at with timestamp. Okay, let's create this table. Mm, what happened? Okay, we can give logs. Okay, this table we will create here. Okay, now you can see we haven't inserted any records in this table, right? So let me give you one select query here. See, so we don't have any records here. So what we are going to do, we will create one DBT model. Okay, and in our post hook, we will add this one insert query, and after that we'll cross check whether record has been loaded or not in this table. Perfect. Now come to our DBT UI. So let's create one more model here. I'm going to use mart folder, and let's give one post hook model name, post hook orders with SQL extension. Yeah, first of all we need to give the config, and materialization we are giving as a table only, and this time I'm going to use post hook, and inside this square bracket we are going to use insert query. Model name, status, and run at. Values, for temporary purpose we can add model name 1, status completed, and current timestamp. Perfect. Let's create one model. We can simply give select star from source function. Source name is raw and orders table. Okay. Let me save it and we will execute our model. DBT run hyphen select with our model name. Post hook orders. This is our model name. Let's run it. Okay, it failed. Let's check. Actually, the issue here, we have given double quotes, right? And here also we are giving double quotes, right? That's the reason it is not working out. So instead of giving this double quote, we will give single quote. Perfect. Let me save it again and let's run our DBT model. Okay, this time it succeeded. Let me show you DBT generated logs as well. Right, so here you can see post hook we are able to see, and let's verify that a particular table whether it's this post hook orders name table created or not, and second this insert query, right, means into this table whether this record has been inserted or not. We can cross check here. So this is a Snowflake UI. Let's run this particular select query. See, so this record has been inserted here, right? So this is current timestamp, completed status we had given, and this is a model name. And also check our table DB schema with the demo schema and post hook orders. See, your model also has been created. So basically, so first run this create table statement directly in Snowflake to create the log table, right? Once the table exists, run your DBT model. Posthook will automatically insert a log entry every build after time, right? Then query the log table and you can see every run with model name, status and timestamp will get updated or inserted in your table. Okay, thank you so much for watching this video. Hi, welcome to this section DBT test. Let me be very direct with you. Data testing is not optional and it is not a nice to have. In production data engineering, data quality issues cause real business problems. Wrong numbers and dashboards, in incorrect reports to leadership, wrong totals in financial systems. These are not abstract concerns. They happen, they cause damage, and they damage your credibility as a data engineer. DBT testing a framework is one of its most powerful feature. It lets you encode your expectations about the data as test, and it verifies those expectations automatically every single time you run your pipeline. If something breaks, DBT tells you immediately before bad data reaches your stakeholders. This section we will make you a data quality engineer, not just a transformation engineer. Okay, so there are six learning objectives for this DBT test. So we will cover these 6 points. First is understand why data testing matters and what DBT test checks. Second uh, is all about add all four built-in generic test, unique, not null, accepted value relationships. And third is write singular test as a custom SQL queries for your business rule. Fourth is run DBT test and interpret pass and fail result. Fifth, configure test severity, once versus error. And last is configure test severity. Store test failures in Snowflake for investigation. Very important section. Let's go through it. There are two types of test in DBT and they complement each other beautifully. First, generic test, and these generic tests are the first type. These are configured in YAML file, specifically in your schema.yaml alongside your DBT models. DBT comes with four built-in generic tests: unique, not null, accepted values, and relationships. And you just declare them in your YAML, and DBT generates the test SQL automatically and it runs it. You don't need to write any SQL yourself for this. They overcome with cover the most common data quality checks. Second is your singular test. So these are custom SQL queries that you write yourself and place in the test folder. The logic is simple and elegant. A singular test is a SQL query that returns row when there is a problem. Zero rows written means the test passes. Right. Third point I have mentioned, DBT test executes all tests, both generic and singular, against your Snowflake models. Okay. The output shows you clear pass or fail for each test, with the model name, column name, and number of failing rows. If any test failed, DBT exists with non-zero status code, important for CI/CD pipelines as it will break GitHub, whatever GitHub actions workflow if data quality degrades. Next, test severity gives you control over how failures are handled. By default, all tests are error severity. A failure stops the pipelines, but sometimes you want to a software approach. If you configure severity 1, a failed test logs a warning in the output, but pipeline continues use 1 for non-critical checks as you want visibility on without breaking production runs. Let's look at how to actually write this test. Hi. In last video, we saw how generic tests work in our DBT, right? Now we will talk about singular test. So singular tests are custom SQL script we can build to test specific values. You can think of it's a query from which you expect zero result. If there are returns row, then the test will fail. These are the defined in .sql files, typically in your test directory. Yeah, here we have that test directory. You can use Ginger templating also. You can use including ref function, source function, many other Ginger templates also you can use. Each .sql file will contain one select statement and it defines one test. Okay, for reference, you can check the test folder in main root of the project, and the folder structure should be mirroring the model folder as well. Okay, now what we can do, we can create one file here under the test folder. So I'm going to create one singular test file here. So singular test, uh, customer. Okay, let's take order ID not null. Okay, so it will also .sql file. Okay, now you can do select. You can take order ID column from the table, and I'm using this fact orders this model we are going to use, and we can add one condition where order id is null. Okay, perfect. So basically we are checking this null value for this particular column, right? So in this singular test, you no need to specify anything in your YAML file, right? It is a straightforward code you have to write in your test folder. Okay. Now what you can do, if you want to test your particular column for this particular model, you can simply put one command dbt test and your model name. Uh, Not model name, means this particular file name you can copy and paste it here. Let's see. See, dbt test succeeded because there is no null value, right? Now we can check for not null one. Okay, what we can do for one particular id, we can update it as a null. Okay, so we can do one more thing. This is our table. For this order id, we can update as null. Okay, and let me change it to update. Let's update it. Okay, so we have one row has been updated with null value. Now rerun this particular test model. See, this time it failed. Why? Because it contains null value. That's how you can test your model right here, like using your singular test. And our last column is unit price. And for unit price, we will check not null. Okay, so I'm going to save this file. And this time we are going to check our fact order table, right? So you need to specify your dbt run command here. But this time we are testing our table, right? So you will use dbt test hyphen select your model name, and model name is fact orders. Okay, our dbt test command succeeded. So here I can see all test got pass, right? So we can do small change here. We can update one column, means we can update it to null. We are updating this order id column, and where order id is 1001. Okay, so basically what we are going to do in order id, for this particular field we are going to null it, right? And after that we will check whether it's failing or it is succeeding while running our dbt test command. Okay, see, it's updated. Okay, so we have only null value here. Let's check now. See, it got failed. Why? Because not null, not null constraint we had added, and there is no any value, there is a null value, right? That's why it got failed. So like that you can use your generic test. Basically you need to specify your all model name you can mention in the single file itself, and after that you can provide your column names, whatever test you are going to use, right? So you can specify here unique, not null, null, something like that you can mention. And there is accepted values also, if there is a true or false is coming, right? So you can mention your accepted values here, and you can do the testing. Thank you. Welcome to this DBT doc section. Here is a common problem in data teams. The data exists in Snowflake, the models are built in DBT, the dashboards are working, but nobody knows what any of the columns actually mean. What does amount used column represent exactly, right? What is the business logic behind the metric? Is customer ID is the same customer, I mean, in the caps customer ID as a lower customer ID column as in the CRM system? This lack of documentation is a huge problem. New team members take weeks to get productive because there is no reference material. Data consumers second guess numbers because they don't understand the definitions. And when a model is updated, nobody knows all the downstream dependencies that might break. So DBT docs solve all of this with single command. Let's see in how. Hi. In this video, we will see how you can generate the documents in your DBT. Once you have carefully described your models, columns, and sources in your schema YAML file, DBT gives you a powerful to generate a beautiful interactive documentation with a single command. Okay, so first of all, you have to come on your DBT UI or DBT Cloud, and uh, in this DBT run command section, you have to provide one command. This is DBT docs generate. So what will happen? It will run and it will process all the models here. Within a seconds, it will get completed, not an issue. See, DBT doc succeeded. Now what you can do, here you can see there is a one panel. So here you have to simply click. So it will redirect you to DBT doc which is this one. So in this page, you can see each and everything. Okay. So here you can see what are the sources you have, what are the projects you have. So as I mentioned in my first video, we are working on demo project. I had given this demo project name. So you can see all the macros, models, seeds, snapshot, everything. I can open this also. In this macro folder, we had created one of the macro file. In the models, we had two folder, mats and staging. Under the mats, we have fact order, post hook orders, pre hooks orders, right? In the staging folder, we have multiple models. Same, we had worked on seeds. So in the seeds folder, we had created one CSV file, which was country code. Again, we worked on snapshot. So snapshot file is there. Testing strategy also is there, right? Singular test. So if we talk about this fact order, if I'll open it, so you can see here there is a details, description columns, referenced by, depends, code, everything you can see here. If we talk about this detail, so it will give you approximate size, last modified date also, and total row count also it will provide you. Description, whenever you will create your schema YAML file, there you can add your description, so it will provide you that. We did not add that, that's why it did not appear here. Okay, and it will give you column details also. What are the columns we have, what is the data type, what are the description, constraint, everything will be here. And it will also show you referenced by, means what are the reference model we are using, where we are giving this one, right? That is also we can see here. Depends on orders table, right? Because this is a source we have. Yeah, and you can see your code also. And there is a best feature is you can see compiled version also of your code. See how it created in the compiled version, which is written in the SQL language. Right? You can simply copy it, run it in your Snowflake for testing and validation purpose. Right? These many things are here. And most beautiful feature is here is lineage. Okay, it will show you proper lineage. It is a straightforward one, but if you will work on a real world project, you will see the lineage feature means it will complex lineage also it will show you like from where to where it is going, right? Multiple joining conditions, multiple uh, where condition also will be there, right? So it will show you each and everything here. So as you can see, this is a source table which is coming in the orders, and this order table we are using in one of the singular test, right? That you can see here, and multiples models also here. I'll show you this one also. See, this is the lineage for our staging order table. See, from source to one model, from one model to another model, how it is referring, you can see here. Now come to our database folder. So under this DB, we have raw schema, we have demo schema. Raw schema is nothing but what are the tables already present in the Snowflake, that is a under the raw schema. Demo schema is the uh, target schema for us to build our all the tables and all. So here I can see all tables you can see here, right, in the database section. And under the group, there is no feature correctly. So you can see two things here, only project and database. Like that, you can share this particular document to anyone, so any team member, so they will look into it and they will have basic understanding on this from where to where our models are coming, how development had happened, like that they can see. Okay, one of the base part of this DBT documentation system is that it lives alongside your code, but just like code, your docs need to be kept up to date, otherwise they will quickly lose their value. Okay, and this is automate process to generate the docs, right? What we had done, we simply put it one command dbt docs generate and it generated everything, right? So that is a best feature in the Snowflake DBT, right? Thank you. And that is a wrap on the DBT Masterclass complete course on Snowflake. I want to take a moment and genuinely acknowledge what you have accomplished. You came into this course knowing little or nothing about DBT, and you have now covered the complete toolkit of professional DBT engineer. Let me quickly recap everything you have learned. You understand what DBT is, where it fits in modern data stack, and why the world's based data teams use it. You have DBT core installed on your local machine connected to a live Snowflake database, right? You have built real SQL model organized into staging and marts layer. You know all four materialization strategies and when to use each one. You have loaded seed data and declared sources with the freshness checks. You have captured historical changes with SCT type 2 snapshot. You have protected your data quality with generic and singular test. You have written reusable macros with Ginger templating. You have generated a beautiful interactive data catalog with lineage graphs, and you have made your pipelines production ready with pre-hook and post-hook. That is genuinely complete professional level DBT skill set. What should you do next? Build something, take a real data set from Kaggle, right? From your company, from your anywhere. Create a Snowflake account if you don't have one, and build a real end-to-end DBT project from scratch. Apply every concept from this course. That is how you take what you have learned from the
knowledge to the skill. If you enjoyed this course, please do leave a review. It genuinely helps other students find the course and helps me to keep creating content like this. My name is Prem Shende. I am a senior data engineer from SGS ITS Indore with over 5+ years of experience, and it has been an absolute pleasure teaching you. I hope to see you in my next course. Thank you so much for watching. Keep building and keep growing. Thank you.